Hello. Okay. Good evening, students. कैसे हो? So, all the students who had attended the previous class, they are right in this class. So they are ready to finish off with electrochemistry chapter. And I believe the students have got a little serious about their course. So am I audible and visible to all of you? Yes, I'm audible and visible to all of you. Great, 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 great. Good evening, everybody. So again, I was looking at the chat that you students are having. So let me have a look at it once again. Okay. So what are the charts that you are having? Let's see. So here, गुड इवनिंग सर होमवर्क कंप्लीट कर लिया सब आपने गुड इवनिंग सर नहीं यार बैक टू बैक क्लासेस ओके प्रेरणा यू हैड द बैक टू बैक क्लासेस टाइम नहीं मिला थोड़ा किया है पूरा होमवर्क नहीं किया ओके प्रियांशु आल्सो सेम हियर गुड इवनिंग सर तीर्थराज आई विल कंप्लीट इट आफ्टर दिस सेशन ग्रेट व्हाट अबाउट द अदर पीपल हैव गाइस डन विद देयर होमवर्क तीर्थराज मुखर्जी नहीं भाई मेरा तबीयत खराब है इसलिए होमवर्क नहीं हो पाया तीर्थराज डजंट मेक अ डिफरेंस आपकी तबीयत कितनी खराब है Okay, okay. After the class, try to complete it and send it to Sir Teethraj. Till the class starts, I'll do the homework. नहीं class था इसलिए प्रियांशु I am also going it doing itself. Sir is live. Sir जिंदा है. Ananya Sakar. So you guys are so obedient. Ananya, do you know if you write it in capitals, it means you are screaming, you are shouting. I'm serious about studies. Good to see the Josh. तीर्थराज अच्छा कोई बता सकता है सर को होमवर्क सेंड कहां पर करें यू कैन सेंड इट ऑन टेलीग्राम और व्हाट्सएप and send it in the group. And I'm going to give you the website where you can send the homework. Yeah, Nanya sir keeps a lot of efforts for us and it's duty to follow our sir and score nice marks in NEET. Great, inactive, interact live with Anoop sir. Yes, that's my Telegram channel. And yes, you all are following only NCRT for chemistry. Yes, for 2024 NEET. Yes, what about others? Yes, one and only NCRT. मैं तो सिर्फ NCRT पढ़ता हूँ. Hello sir, good evening. Yes sir, audible and visible. Hello sir, hello sir. Sir, question practice please. Jyotiraditya Vara. We are doing question practice in the special classes. Special classes you can join. You can just join the special classes using the code AV Live and join there. Now, we have very limited number of students, and this is the topic we are having electrochemistry, the electrochemical cells, electrolysis. Electrolysis, we are going to have the session tomorrow. Tomorrow, we are going to have the session of electrolysis. Today, we are going to finish off electrochemical cells. So, you are here. Let's begin over with the work. Fine. So, here we have that's me, MSc in chemistry, 26 years teaching experience, 10 lakh students here. And to begin with the electrochemistry. Here is electrochemistry. Okay, fine. So we had talked about the electrochemical electrolytic conductance. Now we are going to talk about something called electrochemistry. Now let's see what happens. Now today I have started, since I am going to have only a few students, only a few dedicated students, so I am not teaching you as a YouTube class. What I am doing is I am teaching you as an offline class. The way I would teach in an offline class. So today in the online, you are going to get a feel of offline class. Correct? So let's begin over. No, today, Radhika, I have not put the special class. I can put, but I think that will be too much today. Already we have had 2.5 hours of classes, 2 hours of that class, and then putting a special class at the top of it, it will be too much, isn't it? So now we are going to talk about electrochemical cells. Now, when we talk about the electrochemical cells, let us talk about something called the very first topic called electrode potential. Okay, let's talk about something called the electrode potential. Let's know what exactly is the meaning of electrode potential and what happens. Fine. Let us take a container. And in this container, we take a solution. It's not necessary what solution we have, but it's better to have a solution of an electrolyte. And for our convenience, we take this solution to be, let's say, zinc sulfate. It could be anything. It could be zinc sulfate, it could be copper sulfate, it could be copper chloride, it could be iron chloride, it could be simply water, it could be any solution, doesn't make a difference. Okay? Priya, jeete raho beta, but why, sir? Why? What do you mean by why? What's the problem with why? Okay? Now, we have put the zinc sulfate solution here. And here we put a metal rod. Now, again, that doesn't make a difference what rod it is, but for our convenience sake, we put a zinc rod in it. So we have put a zinc rod in a zinc sulfate solution. Fine. That's what we have done. A zinc rod in a zinc sulfate solution. When we put a zinc rod in a zinc sulfate solution, if I ask you what is going to happen? Now, very obvious answer. If you put a zinc rod in a zinc sulfate solution, nothing is going to happen. So what happens? The answer to it is nothing. But when we talk about chemistry, then nothing also has two ways of happening. Okay? कुछ ना करने के भी दो तरीके हैं. And now what are those two ways? One way is nothing actually happens. You put the zinc rod inside, you take out the zinc rod, nothing happens, no change, nothing. But there is another way. Another way is where a dynamic equilibrium is established. A dynamic equilibrium would mean that something is happening in such a manner that whatever is happening in the forward direction is being balanced is by what is happening in the backward direction. So overall, nothing is happening. Clear? So that is another way of nothing happening. When we talk about chemistry, it is the second way which happens. There are two reactions which are going to take place. Actually, two reactions which are going to take place. One reaction would be that zinc ions from the solution, they are going to accept the electron from the rod. Okay, now these are zinc ions aqueous which are in the solution. They are going to accept the two electron from rod, or zinc electrode you may term it as, and it is going to get converted into zinc solid which is going to deposit on rod. Is it clear? So that is what is going to happen. Now, if this happens, the rod is going to have a deficiency of electrons. Okay. And the solution will have an excess of sulfate ions. Clear? So here, if this happens, rod becomes positive and solution becomes negative. Any kind of confusion there? If this reaction takes place, then rod becomes positive and solution becomes negative. On the other hand, the reverse reaction is also possible. When we talk about the reverse reaction, the zinc solid from the rod can actually lose the electron to the rod, forming zinc ions, which are going to move into the solution, and electrons, which are again going to stay with the rod. Now, in this case, solution becomes positive and rod becomes negative. Now, as you can very well understand, this is what we can term as the reduction reaction. Whereas this is going to be an oxidation reaction. So if an oxidation reaction takes place, the rod is going to get a negative charge, and if the reduction reaction takes place, the rod is going to get a positive charge. Any confusions in this case? Any problems here? So that is what we have as oxidation and reduction reaction in this particular case. Now, having talked about this oxidation and reduction, now none of these reactions is going to continue forever. Let us say if this reaction takes place, then in that case, there is a certain time we are going to get enough of the positive and negative charge separation. That is what is going to stop the reaction. Or I would say that the reverse reaction is going to start. If this reaction takes place after some time, this reaction is going to take place and balance it. If the other reaction takes place, that is going to, of course, be balanced after certain time by the first reaction. Prerna, what do you need to ask? I just said that any of the two reactions can initiate, and once one reaction initiates, the other reaction also will start, and they are going to balance each other. Okay? So I can say an equilibrium will be established. An equilibrium will be established. But even at equilibrium, there will be a charge separation between the rod and the solution. Is it clear? So we can say at equilibrium, there will be a charge separation between electrode and solution. Now that charge separation will lead to a potential difference. Clear? This potential difference which is developed when an electrode is dipped in a solution or electrode is dipped in an electrolyte is termed electrode potential. Clear? Now, this electrode potential, when we talk about, this electrode potential cannot be absolutely measured. So we can say absolute value of this potential cannot be determined. Now, why we can't determine the absolute value of this potential? Because this is at equilibrium. So no net flow of electric current is taking place, and if there is no net flow of electric current, we cannot determine the potential. So that is what we have as the electrode potential. Now, since we cannot determine the absolute value of the electrode potential, we can only compare it. So we can compare this value. Comparison is possible. Now, where do we compare it for? How do we compare it? What is the comparison criteria? And here comes a value, a thing called standard hydrogen electrode. The standard hydrogen electrode. In short, it is written as SHE. Now, what is the standard hydrogen electrode? What is this SHE? Let's find it out. What is standard hydrogen electrode? Standard hydrogen electrode, by definition, is a platinized platinum electrode. Okay, let's talk about the standard hydrogen electrode. Now, what is the standard hydrogen electrode? Radhika, we are going to talk about its potential is considered to be zero. It is a platinized platinum electrode. It is a platinized platinum electrode dipped in 1 molar H plus solution. That is 1 molar strong acid. Okay. Under a constant 1 bar pressure of hydrogen. Maintained at a constant temperature. Clear? Now, this is what we call a standard hydrogen electrode. So, it is standard hydrogen electrode is a platinized platinum electrode dipped in 1 molar H plus solution under a constant 1 bar pressure of hydrogen maintained at a constant temperature, which is usually 298 Kelvin. Now, please remember the temperature is not necessarily 298 Kelvin. It may be 298, it can be something else. But one thing you need to understand is it has been arbitrarily arbitrarily मतलब एवी मानना था मान लिया. That is what we call as arbitrarily given an electrode potential of 0 volt. So it has been given an electrode potential of 0 volt. Now, whenever we determine the potential of any cell or any electrode, it is in comparison to the standard hydrogen electrode. Is this clear? So this is always in comparison to the standard hydrogen electrode, which has been arbitrarily given the value of 0 volt. So whenever we club any electrode to the hydrogen electrode and we determine the cell potential, that cell potential is simply considered the potential of the electrode. Jyotiraditya Vara, beta, our class has certain rules. And those rules are, first one, never discuss religion, politics, or cricket. So don't discuss these three things here. Okay? Fine. So, clear? Now, so that is what we have as the potential. Clear? So that's what we have as electrode potential. So electrode potential is the potential of an electrode in comparison to the standard hydrogen electrode. Clear? Now, one thing is very clear. One thing you need to understand. Potential is not actually of any element, compound, or a solution. No. Potential is not of the substance. Potential is always of a process. Okay. When we talk about the electrode potential, it is of a half reaction, which may be a reduction reaction, maybe a oxidation reaction. Most often we are talking about that. Clear? So, potential is not of a substance, but a process. Clear? electrode potential is of half reaction. Now, this half reaction could be oxidation or reduction. Is it clear? So please remember, hydrogen does not have an electrode potential, or lithium or chlorine does not have an electrode potential. The potential is of the reaction, either reduction reaction or oxidation reaction of that particular substance. And as far as hydrogen is concerned, we could have a reduction potential, we could have an oxidation potential also of hydrogen. Hydrogen, please remember. I'm perfectly fine, Harsh. How are you? And how many students am I having? 4. So anybody who has joined us and not marked the attendance, that is, you have not liked the session, go ahead and like it. So when we talk about the oxidation or reduction reaction, that could be something like for convenience or convention, we use reduction reactions for comparison. Okay. So when we talk about the electrode potential, Harsh, you are not fine? Okay, yeah, that's great. If you're not fine, that you should be thick. Fine is very thin, isn't it? I'm fine. So you might not be fine. Okay. So we use reduction reaction for comparison. So in case of hydrogen electrode, the reaction that we talk about is H plus aqueous plus electron, giving us half H2 gaseous. So that is what we have as the reduction reaction of hydrogen electrode. You can multiply the entire equation by 2. Sometimes people don't like the fractions. You can write this reaction as 2H plus aqueous plus 2 electron, giving us hydrogen gaseous. Not a problem. No difference. Potential is intrinsic quantity. If you have attended the thermodynamics chapter, there I told you what is intrinsic and extrinsic quantity. Yesterday itself, we had the thermodynamics class where I told you what is intrinsic, what is extrinsic quantity. Potential is intrinsic. So, balancing does not affect. So, that's what we need to understand. So we can talk about the reduction reaction of hydrogen. So we are going to compare all the reduction reactions. Something like when we talk about zinc, I told you there are 2 reactions. So we are going to talk about Zn2 plus aqueous plus 2 electron. That gives us Zn solid. Now, the potential in comparison to hydrogen electrode. Now, we have talked about something like potential. We can get the potential of any electrode. And there is something called the standard electrode potential. Let's talk about the standard electrode potential. Okay, standard electrode potential. So what is standard electrode potential? Is the potential of a reduction reaction compared to standard hydrogen electrode when concentration of all reacting ions is 1 molar. Okay, partial pressure of all reacting gases is 1 bar at 298 Kelvin. So that is what we term as the standard electrode potential. So it is a potential of a reduction reaction. Fine. So it believes that Ananya Sakar has attended the thermodynamics class and so she knows that intrinsic quantity. What are the intrinsic quantities? So those who have not liked as yet, please go ahead and like the session. So this is what we have as the reacting gases, 1 bar at 298 Kelvin and the potential of the reduction reaction. This is what we call as the reduction reaction. Now, having talked about the potential of the reduction reaction, when we talk about standard electrode potential, the electrode potential may be negative, may be positive. Like when we talk about Zn2 plus 2 electrons gives us Zn, this reaction has a potential E naught of Zn2 plus 2 Zn. This is how we write the reactant. This is the reactant. And this is the product. Since the product is the reduced part, that is why this is a reduction reaction. Now that is equal to minus 0.76 volt. Okay, that is the potential which has been measured in comparison to standard hydrogen electrode. In the same manner, if we talk about Cu2 plus 2 electrons gives us Cu. Now here E naught Cu2 plus 2 Cu gives us plus 0.34 volt. Now you might be saying that, sir, is it the positive and neutral? Is it necessary? No, it is not necessary that it is going to be positive and neutral. It is could be something like we could have Cu2 plus electron giving us Cu plus. Now that could be E naught Cu2 plus 2 Cu plus. Now that's something like 0.5 volts. Sir, in NCRT it is written a negative electrode potential that the rock couple is stronger reducing agent. That is, what does this mean? I'm going to tell you, Ananya. At this moment, we are just talking about that it could be positive or negative. We are just talking about it. We are going to talk about its meaning as well. Okay. So that could be both positives, and then it could be something else also. Like we could have MnO4 2 minus. No, it is MnO4 minus. We can have put a plus electron. This can give us MnO4 2 minus. Now that also exists. So here it is going to be E naught of MnO4 minus to MnO4 2 minus. So that also could be possible. This also is a change. Then we could have something like Fe3 plus electron gives us Fe2 plus. So it could be E naught Fe3 plus to Fe2 plus. It's actually 0.77 volt. That's equal to mine plus 0.77 volts. Okay. And then we could have like F2, half of F2 plus electron gives us F minus. Now this E naught turns out to be F2 by F minus. You can see that could be neutral, that could be negative, that could be positive, and that comes out to be plus 2.87 volts. Okay. So the electrode potential could be positive, the electrode potentials could be negative, the electrode potential could be having both positive species, that could be having both negative species, there could be one positive, one negative, that could be one negative, one neutral, neutral, positive, any kind of combination could be there for a reduction reaction. Where to where we are going, depending on that, the reduction reaction is going to change. Is this clear? So that is what we have as the various reduction potential or half cell potentials. Now, as you have seen that these potentials could be positive, these potentials could be negative, these potentials could even be zero. What does that mean? Remember, potential is thermodynamic term. It's an intrinsic, thermodynamic intrinsic quantity. So it gives the feasibility of the reaction. So potential gives you the feasibility of the reaction. If you talk about the potential of the half reaction, it gives you the feasibility of the half reaction. If you talk about the feasibility, the potential of the complete reaction, obviously complete reaction also is going to have a potential. It gives the feasibility of the complete reaction. So potentials actually give you the feasibility of the reaction. विजय कटारिया कह रहे हैं सर हिंदी का नाम सुना है क्या? बेटा मेरे हिंदी का नाम सुनने से आपको क्या फर्क पड़ता है? आपको क्या आपत्ति है मेरे हिंदी नाम सुनने या ना सुनने से? मुझे यह समझ में नहीं आता कि किसी भाषा के नाम पर आपको ये ईगो क्यों आ जाती है? ये भाषा इस व्यक्ति को नहीं आती, इस भाषा का प्रयोग ये व्यक्ति नहीं करता, ये व्यक्ति इस भाषा में ही क्यों बोलता चला जा रहा है? भैया भाषा की बात नहीं है, बात सिर्फ इतनी है कि अंग्रेजी भाषा का प्रयोग आपकी एमबीबीएस की तैयारी में, आपकी पढ़ाई में किया जाता है। आपका जो कॉलेज होगा जिसमें आप जाएंगे उसमें एमबीबीएस की पढ़ाई आपको अंग्रेजी भाषा में करनी होगी। सारी की सारी अच्छी अच्छी किताबें अंग्रेजी भाषा में हैं। तो यदि आप इस समय अंग्रेजी भाषा पढ़ लेंगे तो क्या दिक्कत हो जाएगी? मैं अंग्रेज दिखता जरूर हूं नहीं। और यदि आप यहां पर अन अकेडमी पे ढूंढेंगे तो आपको मेरे शुद्ध हिंदी के सत्र प्राप्त हो जाएंगे। ठीक है? अन अकेडमी पर एक लक्ष्य बैच था। ठीक है? विजय, नीट विजय ढूंढो, मिल जाएगा शुद्ध हिंदी का, इसलिए मुझे मत बोलो। ओके विजय कटारिया, so you have seen the Hindi. Now let's get along with English. Now, so potential is thermodynamic term. It gives the feasibility of the reaction. More positive is the potential, more feasible is the reaction, more spontaneous is the reaction. Yeah. But now, as you have very well seen, that these potentials are in comparison. So quite obviously, the feasibility also will be in comparison. It's not going to be absolute, it's going to be in comparison. Clear? So, potential gives the feasibility or spontaneity. Okay? More positive is the reduction potential. Easier is the reaction, or I should say reduction, compared to reduction of H plus. That is, more favorable is the reaction in comparison to the conversion of H plus to hydrogen. Fine. So that is what we have as the reduction potential. Now, so it is that much easier. Now, if a species is easily reduced, it is going to accept the electron that much easily. And if it is accepting the electron that much easily, it is that much strong oxidizing agent. Okay? Stronger oxidizing agent is the reactant. So that is the confusion. That is the thing. Fine. So that is what we have as the potential. That is what we have as stronger oxidizing agent is the reactant. So if we talk about F2 plus electron giving us F minus, the potential is E naught is equal to 2.87 volt plus 2.87 volt. It is the strongest oxidizing agent. Okay. So that is what we have as the positive potential. Now let us understand what is the meaning of the negative potential. Clear? So let's talk about the meaning of the negative potential. Now we have lithium plus aqueous accepting the electron to form lithium solid. So lithium plus aqueous plus electron lithium solid, and this E naught Li plus 2 Li is actually minus 3.05 volt. Now, you might be thinking about, sir, do we need to remember these values? No, you don't need to remember these values. All these values are going to be given in the examination if required. So any of the values that is required would be given in the examination. So you don't need to worry about it. So E naught Li plus Li is equal to minus 3.05 volts. If it is minus 3.05 volts, that simply means it is extremely difficult to reduce. Means reduction reaction is more difficult than reduction of H plus. ओके अनन्या ऐसी स्पीड से पढ़ा रहा हूँ डोंट वरी समझ में आ रहा है ना दैट्स गुड बट बाकी लोगों को शायद समझ में नहीं आ रहा वी हैव 7 स्टूडेंट्स वेटिंग so we have 6 students. I believe these 6 students are able to understand, so I'm going to teach only for these 6 students. बाकियों का पता नहीं. Okay, so this reduction reaction is more difficult than H plus, reduction of H plus, but the product of the reduction, and that's lithium, will be very easy to oxidize. Now, if I talk about lithium solid going to lithium plus aqueous plus electron, if I talk about this lithium solid giving to lithium plus aqueous and electron, this is going to have E naught of lithium to lithium plus as plus 3.05 volt. Please remember, this is not the oxidation potential of lithium plus. This is the reduction potential of lithium plus. This is the oxidation potential of lithium. Both are not same. There was a confusion here. Sir, if a body has a higher positive potential, negative potential, this was a confusion. Clear? Now, so this lithium to lithium plus 3.05 volt, that makes lithium the strongest reducing agent. So more negative is the reduction potential, a stronger reducing agent, the product of the reduction reaction becomes. Fine. So if zinc has a reduction potential, Zn2 plus has a reduction potential of minus 0.76 volt, it would mean zinc has an oxidation potential of plus 0.76 volt. Zinc has a tendency to get oxidized, and zinc is a reducing agent. Any kind of confusion? Now, all these species, the reactions can be arranged in a series. Please remember, if you look at the NCERT and you look at this particular series, you would find that the reactions are mentioned. Okay, just a minute. Just a minute. I'll just show it to you. See, this is the series in NCERT, and this is what is written as standard electrode potential. Now you can very well, very nicely see that these potentials are the reactions. It is not just a species which has been mentioned, the reaction has been mentioned. And here the potential has been mentioned, 2.87 volt, I told you. You don't need to remember it. These values will be given to you. This is the reaction given in your NCERT. Can you see that reaction is given in the NCERT? Here is the reaction given in the NCERT, and this is the standard hydrogen electrode, which has been given the value of 0 volts. Here, as you can very well see, increasing strength of reducing agent, this products. And here it is increasing strength of oxidizing agent, the reactants. Clear? Please remember, reducing agents are the products. Oxidizing agents are the reactants, because reactants are undergoing reduction and products are going to undergo oxidation if the reverse reaction is talked about. So this is what we have as the electrochemical series. This is electrochemical series. This is a thermodynamic series. This is not kinetic. This is, sometimes people tend to say the reactivity series. No, this is not the reactivity series. It does not give you the speed of reaction. It only gives the feasibility of the reaction. It is thermodynamic series. So the standard electrode potential is a thermodynamic series. Clear? It does not give the speed of the reaction. Most often, the speed and the this particular series, they match. Most often they match, but they are going to match always. That is not true. And the typical example is that if you talk about the reactivity series, sodium is much higher than calcium. But if you talk about thermodynamic series, calcium is higher than sodium. Calcium reacts slower than sodium but releases more energy. Is it clear? Snehal, what do you want to ask in one more time? Please write the question completely, because here we are having a near about 20-second delay between your question and my telling something. So I move 20 seconds further, and when you say, sir, please tell us once again, I don't know what I need to tell once again. Is that clear? Whoever has not liked the session, go ahead and like it. So that is what we have a standard electrochemical series. That's electrochemical reactivity series, not the reactivity series, the thermodynamic series. Now this series is in the order of reduction potentials. So we have just made it in terms of reducing reduction potential, decreasing reduction potential. In the same manner, a series can be made in increasing reduction potentials. Is this clear? Yes, Ananya. There are one shot series in the YouTube, of course, and there are question series also in the YouTube. You can go on my personal channel as well if you wish to. Okay, there also we are going to have all of these things. Fine. So that is what we have as the standard electrode potential. See here, this is the statement that you were talking about, Ananya. A negative E naught means the redox couple is a stronger reducing agent than H plus H2 couple. Perfect. A positive E naught means that the redox couple is a weaker reducing agent than H plus H2 couple. And a positive E naught means Yeah, perfect. Negative means the redox couple is a stronger reducing agent than H plus H2 couple. Okay, it's the other way around they have written. Why do you want they die, right? Well, the statement is absolutely true. That is not a problem. Statement has no problem, but the statement has been written reverse. Actually, they should have said a positive E naught means that the redox couple is a good oxidizing agent as compared to H plus H2 couple. So rather than writing that, they have written as weaker reducing agent. Okay. So that is what we have as the electrode potentials. Okay. So we've just found the meaning of the electrode potentials. We have just got what exactly it is. Now, so we have understood the meaning of the positive electrode potential. We have understood the meaning of the negative electrode potentials. We have understood what the electrode potentials are and arranging the various reactions in order of their potentials, the reduction potentials, is termed as electrochemical series. Electrochemical series is arrangement in order of electrode potentials. Arrangement in order of electrode potentials. Okay, Snehal, I believe now it is very clear to you. It is written actually opposite. They have written the redox couple, where it's not actually a redox couple. Okay, it is actually a simple reduction reaction, half reaction. Fine. So that is what we have as electrode potentials. Okay, is termed electrochemical. Now these are the half reactions. These are one electrode reactions. Now we are going to create a cell. Clear? We have electrochemical cell. Okay. Now, first of all, the electrochemical cell is a redox reaction. So it has a reduction electrode where reduction takes place, where reduction takes place. And then there is an oxidation electrode, quite obviously, where oxidation takes place. So there is a reduction electrode, there is an oxidation electrode. The reduction electrode is where the reduction takes place. The oxidation electrode is where the oxidation takes place. Now the reduction electrode has a specific name. The electrode where reduction takes place is called the cathode. And the electrode where oxidation takes place is termed as the anode. Now, quite obviously, the species which has a higher tendency to get reduced will form the reduction electrode. Means the cathode is the electrode which has a more positive or less negative E naught. The one which has E naught, or you may even say E, the potential, the electrode potential, which has less negative electrode potential. And quite obviously, the oxidation electrode would be the one which is reluctant to get reduced. And the product has a tendency to get oxidized. So the oxidation electrode is formed by the anode is formed by the one which has more negative or less positive electrode potential. Okay, प्रेरणा is informing me, sir पानी पी लीजिए. कोई नहीं पी लेंगे. My watch has also capacity to inform me of pani. Clear? Now let's have a simple question. Very, very simple question. I have E naught Zn2 plus 2Zn is equal to minus 0.76 volt. And I have E naught Cu2 plus 2Cu as plus 0.34 volts. So these are the two potentials. Can anyone tell me which of these would be preferably the cathode and which of them will be preferably the anode? So question is, which would prefer to be the, let's say, cathode? Which of these two will be the cathode? Let's say this one is A, this one is B, just for you to write the answer. Which of these will be preferably the cathode? For the overall reaction to be spontaneous. Answer. Hmm. Priyanshu has given me the answer. Second, Priyarna, Ananya, Radhika. Where are the others? There should be 6 answers, isn't it? Only 6 answers. A very, very small class. It was something like individual tuition class. I didn't ask you the reason, Ananya. I simply asked you the answer. Okay, you have given me the answer. I told you the one which is having more positive reduction potential will be the cathode. So, copper electrode is cathode. Okay. Now, when we talk about the copper electrode, the copper ions will be consumed. When we talk about zinc electrode, zinc rod will be consumed. Clear? So zinc is going to get oxidized. This will be getting reduced. This will be the anode. This will be the cathode. Here, zinc is consumed. Zn2 plus is formed. Here, Cu2 plus is consumed. Cu is formed. Confusion? So, the overall reaction that is going to take place. Oh, we are going to talk about the overall reaction very soon. But before we talk about the overall reaction, let us talk about the cell diagram. Cell diagram. Then we have cell representation. And we have cell reaction. So we have cell diagram, cell representation, and the cell reaction. Any confusions here? Okay. Let's talk about the cell diagram. Now just remember, in all these cases, anode is always on left side. If you somehow write the cathode on the left hand side, then it will be considered anode. And the cell reaction is going to become non-feasible. So don't ever do it. If in an exam it is written on the left hand side, just consider it on the left hand side to be the anode and solve accordingly. You would be getting the negative value and just write the reaction is non-spontaneous. Anyone has to ask anything and everybody has shifted. Where are they? Internet issue? Beta, this is a unique opportunity that you are having, that you are able to study as if in an individual class. Just don't let your internet connection hamper you. Just don't do it. Within a few days, we are going to do many chapters. We are going to have many marathon classes. We actually are lagging at the moment. So we are going to have many marathon classes. We are going to do it very nicely. You might have done the chapter earlier, but this is going to be a unique opportunity for you. So just don't let your internet speed harm you. Clear? Okay. So what we do is the anode is zinc rod. Let's write it. So this is the zinc electrode that we have. And here we have zinc sulfate solution. It's not necessary that it has to be a zinc sulfate solution. It's not even necessary that you are going to have some zinc solution, because zinc rod is to be consumed. The solution might be anything. It could be simply water, because zinc ions are going to move into the water anyway. We don't need the zinc ions in the solution. Then we have another. Here we have another rod, and that's the copper rod. Here the solution is copper sulfate. Now it's not necessarily that it has to be copper sulfate. It could be copper chloride, it could be copper nitrate, but it has to be copper because the solution is to be consumed here. Rod can be of anything. It's not necessarily copper. It could be anything else also. The copper is going to deposit there. Fine. Now here we have the solution. And here we attach the two rods through a load. It could be ammeter, it could be voltmeter, it could be a bulb, it could be anything. Clear? Yes, Prerna, that's what I'm saying. Okay. This is indeed a rare opportunity because a teacher, it would be like a bragging, isn't it? It would be a bit of bragging, but having 26 years of teaching experience and teaching in this manner is extremely difficult. I have got a unique opportunity and you have got a unique opportunity. So we have to make the best of these opportunities. Is it clear? Tomorrow again, we are going to have a long class. From now on, we are going to have only long classes. No short classes are going to be there and multiple classes in a day. Is there anybody in this particular session, in this particular class, who is not a dropper and who has a problem in taking the class in the morning? Anybody who has to go to school or he has a problem, he, she has a problem in having the class in the morning's time? Anybody? Tell me if anybody is there. But now what is going to happen is, I perfectly understand that zinc rod is going to have a comparative negative charge. I believe in the starting itself, I have told you that the electrode where the oxidation takes place is going to get a negative charge. And this copper rod is going to have a positive charge. But the moment the two rods are going to be connected, the charges are going to neutralize each other. Okay, so this is going to be an elite batch on YouTube and the plus classes and the special classes. This is the elite batch. So that is how the things happen. I have been trying to create an elite batch for such a long time, but now it has been created. Anne, which college are you gonna take the admission in? Are you not preparing for NEET examination for the next year? Whoever has not liked, go ahead and like it. There are only 4 people. So the moment we connect it, it's going to become neutral and the current flow is going to stop. To continue the flow, the solutions must be neutralized. The solutions must be neutralized to continue the flow of electric current. Now, how do we neutralize the solutions? And here comes the very famous salt bridge. Salt bridge. Let's know what is salt bridge. Salt bridge is a saturated solution of a strong electrolyte. And strong electrolyte means salt. Supported on an inert medium. Now, that inert medium is actually there to prevent the flow of the solution. Ananya, the partial drops, they are actually harmful. You won't be able to do your college, you won't be able to prepare. So that's going to be a little difficult. But I hope, I don't know about other subjects, but in chemistry, I hope I would be able to get you 180 out of 180 if you are regular and I'm also regular. Okay. So saturated solution of a strong electrolyte salt supported on an inert medium is termed as a salt bridge. Inert medium could be silica gel, it could be agar-agar, it could be gelatin. That these are the three examples which are given in any of the book, but it could be a filter paper, it could be a muslin cloth, it could be simple cotton, anything which remains soaked in the salt does not allow the flow of the solution itself, but allows the ions to move through. That is going to work. Okay. So that is what we have as a salt bridge. Now, the salt bridge is going to be placed right here. That is the positioning of the salt bridge. Now, what does salt bridge do? Now, before that, let us understand what is the meaning, what is the possibility of the salts. Okay. The salt must satisfy two conditions. First, it must not react with any of the electrolytes in any of the half. Let us say the half cell contains silver, then the salt bridge cannot have chloride. If it contains maybe lead, it can't have sulfate, it can't have chloride. So that is what we need to understand, that we can't have any of the solutions which are going to react with it. And second, the ions, that is the cation, anion, must have similar mobility. They must travel similarly, so they must carry around same charge, amount of charge. Now for that, we may have certain cations and certain anions, like we have K plus, we have NH4 plus, they have identical mobilities. And in case of anions, we have Cl minus, we can have NO3 minus, and we can have SO4 2 minus. So overall, we have 6 salts which can be used in salt bridge. That is potassium chloride, potassium nitrate, potassium sulfate, ammonium chloride, ammonium nitrate, and ammonium sulfate. So these are the 6 salts which can be used in the salt bridge. Is this clear? Any doubts? So that is what we call a salt bridge. Now let's talk about the functions of salt bridge. The very first function, it completes the circuit. Completes it. Second, maintains electroneutrality. Electroneutrality would mean that it keeps the solution neutral. The solution does not remain charged, they remain neutral. So that is what we call as electroneutrality of the solution. And please remember, to maintain that electroneutrality, salt bridge is consumed. Okay. To maintain electroneutrality, the salt bridge is consumed. Wherever is the positive charge, the negative ion of the salt bridge moves into that. Where is the negative charge, the positive ion of the salt bridge moves into that. So salt bridge is consumed as the reaction proceeds. Is this clear? And there is something called it prevents liquid junction potential, but that is not in your course. So that I'll just write it. Prevents liquid junction potential. Is this clear? So these are the functions of salt bridge. Now, we are going to talk about the representation of a cell. We have talked about the cell diagram. Clear? So this is what we have as the anode. This is what we have as the cathode. And please remember, cathode is the positive terminal. And anode in the electrochemical cell is the negative terminal. Is this clear? I hope you are not tired at the moment. Yeah, you are tired, but can't help it. If you are getting tired, you can see the recording if you wish to. But then I'll be not having even 5 students here. So that's what we have as the salt bridge. We have cathode and we have anode. And now we are going to talk about the cell representation. We have talked about the cell reaction, cell representation we are going to talk about. So let's talk about cell representation. What is cell representation? Cell representation is the flow of positive charge within the cell. Okay. Cell representation is the flow of positive charge within the cell. So the salt bridge is consumed. That's why after a certain time, cell doesn't supply energy further. Priyanshu Ghosh, salt bridge is always the last thing to be consumed because it's quite cheap. Salt bridge is not a costly item. Rather than the salt bridge, it is either the cathode or the anode which is consumed first. Like when you talk about the zinc cell, the dry cell, it is the zinc casing which is consumed the first. Is that clear? So cell representation tells you the flow of the positive charge within the cell. So if we talk about this particular cell, like we have this zinc cell, cell diagram we talk about. This is the copper one. Here we have the zinc rod. This is what we have as the zinc sulfate solution, or any other solution, doesn't make a difference here. Here we have copper sulfate solution. And here we have the copper rod. And again, here any rod would be fine enough. It could be platinum, it could be copper, it could be anything. Here we join the two. And here is the salt bridge. Now what happens is that the zinc ions move from the rod to the solution. So here the zinc ions move from the rod to the solution. Okay. Then the negative ions move from the salt bridge to the solution. So the salt bridge becomes positive then. Now there comes the positive charge in the salt bridge. Next, what happens is the negative ions from the salt bridge, they move into the zinc ions. The positive ions from the salt bridge move into the copper sulfate. Then copper ions, they convert to copper and they deposit on the rod. So if I talk about the flow of the positive charge, it is going to be from the zinc rod to Zn2 plus solution or whatever is present in the solution. So from zinc, it goes to Zn2 plus. From Zn2 plus, it goes to the salt bridge. From the salt bridge, it goes on to the copper sulfate solution. From the copper sulfate solution, it goes to the copper rod. So that is the flow of the positive charge in the cell, not in the external circuit, but in the cell. Now, how do we represent as a cell representation? Please remember, if we have a difference in the phase, that is, we have solid, liquid, liquid gas, solid gas, then we separate it by a solid line. How do we do that? Zn solid slash Zn2 plus. They have different phase. So here we are using a solid line to distinguish between them. And then we put the concentration also, concentration of Zn2 plus. We can always mention it. A double line, double parallel line is used to represent salt bridge. Then we go on to copper 2 ions. That is again Cu2 plus. You can put it here. Aqueous. And then the end is copper. We put the temperature. If the pressures are involved, gases are involved, the pressure is there. Now, this left electrode is again the anode. So, the left electrode is the anode. The oxidized part is the product. Forget about left and right. The oxidized part is the product. Right hand side is the cathode. The reduced part is the product. Anode, oxidized species is product. Cathode, reduced species is product. I don't know how much you will be able to learn. Prerna, yes, you should add this session notes in the homework PDF. Yes, you should. This term for EMF is the same for physics and chemistry. It is same. What do we do if more than one option are correct in the NEET examination? Only one of the option is correct, beta. Not more than one option. If you feel that more than one option is correct, then mark the more appropriate one. Okay. Cathode is not reducing. Cathode is the electrode where reduction takes place. Okay. Cathode is reduced. Fine. Just don't get confused with English. I hope if you are attending these classes, a little bit of improvement in English also is going to take place and you might be saved from getting confused in the questions. Many times question asks something else and you understand something else. Is that clear? So this is what we have as the cell representation. Now, once we have talked about the cell representation, now let's talk about the cell reaction. Now, there are two reactions. The two reduction reactions are there. One is Zn2 plus aqueous plus 2 electrons, giving me Zn solid. Okay. Then there is another reaction. We have Cu2 plus aqueous plus 2 electrons, giving us Cu solid. Okay. Now, this reaction actually does not take place. The first reaction does not take place. The reverse of the first reaction takes place. Okay. Let's say if this is 1, this is 2. The final reaction, the cell reaction, is 2 minus 1. Any kind of confusion here? Why it should be 2 minus 1? This is reduction, but actually copper, zinc is getting oxidized. Okay, that's why it is 2 minus 1. Now, if I do it 2 minus 1, then in that case, I get the reaction as Zn solid plus Cu2 plus aqueous gives us Zn2 plus aqueous plus Cu solid. So this is what we have as the cell reaction. Okay. These are reactants and these are products. And then what do we need to ask? Tell me what is being asked. बोलो अनन्या, क्या पूछना है? फिर क्या बताना है? मैं तो बहुत सारी चीजें बता चुका हूं, क्या बताना है इसमें? Anyone has to ask anything? Ananya, you have not told me what needs to be told. क्या बताना है? Anybody who has not liked the session, go ahead and like the session. So it is going to be the cell reaction. Okay. Now we need to get the cell potential. Cell potential. Now cell potential is the same as the cell reaction. Since we have done 2 minus 1, the potential also will be 2 minus 1. Fine. Cell potential. Clear? So we have E cell, or you may say E not cell. Final result कैसे आया? Ananya, just subtract it. Just subtract it. This will be written as Zn gives us Zn2 plus 2 electron. This is written as Cu2 plus 2 electrons gives us Cu. We are subtracting the first one. So here 2 electrons and 2 electrons gets cancelled out. That's it. Just add them. Okay. Now, when you talk about the cell potential E naught cell, now E naught cell is equal to E naught of cathode. That is what we had written as a second reaction, minus E naught of anode. That is equal to E naught reduction electrode. Remember, cathode is the reduction electrode where the reduction is taking place, minus E naught oxidation electrode. Is this clear? Now, and that is going to be E right minus E left. So that is how we find the cell potential. Till this point, everything absolutely clear? So could we find the E naught of the zinc copper cell? E naught of ZnCu cell? Zn2 plus 2 Zn is equal to 0 minus 0.76 volt. Cu2 plus 2 Cu is plus 0.34 volt. E naught of the cell, which is going to be, now I have written the definition formula. Give me the answer. Answer, answer, answer. Ananya. Hey Ram. E cell will be equal to E naught Cu2 plus 2 Cu minus E naught Zn2 plus 2 Zn. Hmm. That would be equal to plus 0.34 volt minus 0.76 volt. That will be equal to plus 0.34 volt plus 0.76 volt. Hmm? Ananda Saga, this silly mistake is going to cost you a lot. Just don't do the silly mistake, otherwise the purpose of this particular batch is defeated. Why did you do opposite? Why? No, you are not allowed to do it opposite. Yes, it is 1.1 volt. I know it. It has been 1.1 volt for the time immemorial. The day Mr. Volta and Coulomb and Galvani, they discovered this electricity. Till from that time onwards, it has been 1.1 volt. So you don't need to tell me that this is 1.1 volt. This has been 1.1 volt forever. But why did you not get it 1.1 volt? And then you say that you don't commit the silly mistake. बेइज्जती करवाओगे तुम मेरी. This is the elite batch. Mr. Anoop Vashishtha elite batch, whom he wants to get 180 out of 180. They were not able to get because of silly mistake, isn't it? So the answer is 1.1 volt. Okay. Now we get on with a very, very important thing. Do you have something in you or you are gone? It's only been 91 minutes as yet. We have 91 minutes more. Okay. So here we have something called the Nernst equation. The Nernst equation. We are not going to go into the derivation of Nernst equation. We are just going to go into the use of the Nernst equation. How do we use the Nernst equation? Clear? So Nernst equation is which gives the relation between cell potential and concentration. The Nernst equation gives the relation between cell potential and the concentration or maybe partial pressures. Okay? The equation is quite simple. E is equal to E naught minus 2.303 RT by NF log Q. This is the equation, the Nernst equation. Now, this is valid for cell or electrode. You can use this equation for an electrode, you can use this equation for a cell, doesn't make a problem. Clear? Now, this E is the cell potential, which we are going to calculate or which might be given to us. E naught is the standard potential. R, quite obviously, gas constant. The value which we are going to use is 8.31 joules, Kelvin inverse, mole inverse. T is temperature, which is most often 298 Kelvin. And F is what we call as Faraday. Now, Faraday is 96500 coulombs. And sorry, the NCRT has given it as 96487 coulombs. That's the value NCRT has used in all the expressions. Clear? Now, here there are two things which you need to understand. N. N is the number of electrons involved in balanced equation. It could be half reaction, it could be complete reaction, but N is the number of electrons involved in balanced equation. And Q is the reaction quotient. Okay. Have you noted it down? Okay, noted. Fine. Now, N and Q change with balancing and with reaction. You change the reaction, and then Q would change, and the balancing, if you change, and then Q would change. But N and Q compensate for each other. If you change the balancing of the equation, N and Q both are going to change in such a manner that the potential does not change. So potential does not depend on balancing. So potential does not depend on balancing. Not much, Ananya. We might be using the word log a lot, but we don't use it much. Only the word is being used. We don't do much of the calculation with log. Is this clear? Okay. Now, N and Q change with the balancing and with the reaction compensate for each other. So potential does not depend on balancing. Now, what we can see is 2.303 FRT. They actually are constants. This is a constant. Yeah. So 2.303 RT by F. That's equal to 2.303 into 8.314 into 298 divided by 96487. Should we calculate it out? Okay, I'm going to calculate it. Calculator. I can actually have this particular window. Hmm. Okay, here we have the calculator. So what we can have is 2 2.303 into 8.414 into 298 divided by 96487. Now that's equal to 0.05984. How does it coming out 84? I believe we should have 96500 or we should have a lower value. Hmm. I think this value should be different. Into 298 divided by 96500. Okay, fine. Now, this value is generally, when we talk about the exact values of all these conditions, this comes out to be 0.0591. Oh, good. Thanks, Tirthaj. Let me check out what the problem was. Okay, so I made a mistake. Great. It's 2.303 into 8.314 into 298 divided by 96487. 487. That's equal to, yes, that's 0.0591. I was thinking about why I'm getting it wrong. Got it? That I like very much. I can show you everything. So from next time onwards, if we have an experiment, I'll show you the experiment as well. We can do it everything. We have a very few number of students and we are going to take the absolute advantage of less number of students in our class. So this is 0.0591. And so our equation actually becomes E is equal to E naught minus 0.0591 by N log Q at 298 Kelvin. Absolutely clear? Now let's have an example of an equation. An equation. An equation is which one I should take? I should take this one. MnO4 minus plus H2C2O4 plus H plus giving us Mn2 plus CO2 plus H2O. Now this is the reaction of potassium permanganate with oxalic acid. Can you balance this equation? Let us see who amongst you is able to balance this equation. Balance, balance, balance. It's a redox equation. Balance it. 9 students here. Balance this particular equation. Give me the actual value, the stoichiometric coefficients. Balance, balance. Yes, sir, balance. And whoever has not liked the session as yet, like it. Tomorrow we are having the session at 4 p.m. It's going to be consisting of electrolysis and it's going to also go on long. That's going to be 2MnO4 minus plus 5H2C2O4 And here we get 2Mn2 plus 10CO2. And then we have water. We have 5 plus 5 fours are 20, 28, and we have 20. So here we have 8H2O. And here we have 10 hydrogen already there. We have 16, so it is 6H plus. This is the equation which is balanced. तीर्थराज क्या कर रहा है यार? रिडॉक्स इक्वेशन है. Hit and trial method doesn't work with the redox equation. Tirthraj, what are you doing? Should I be taking a redox equation chapter also? Balancing of redox equations. I think that would be required. Well, anyway, our sessions are going to be dependent only on these 6 people who are there regularly in the class. Ananya, hold on. At least do this. You are not able to balance this equation, Ananya. Organic, inorganic. 4H plus. Prerna, I have already given you the answer. I believe we'll have to take a very important session on balancing of redox equations. We'll have to take it. There are 6 students in the class. I hope these students are going to be regular in all the classes. Now, if I talk about Q here, Q is the product of the concentration of product divided by the product of the concentration of the reactants. So Q is going to be equal to concentration of Mn2 plus, that is the product, raised to power its stoichiometric coefficient into the concentration of CO2 raised to power its stoichiometric coefficient. Water is a solvent. Solvent does not come in the equation. In the equilibrium equation or the kinetic equation, we don't talk about the solvent. Divided by MnO4 minus into H2C2O4. This is going to be raised to power 2. This is going to be raised to power 5 into concentration of H plus raised to power 6. Now, this is the value of Q. And when we talk about N, now MnO4 minus, it accepts 5 electrons to give Mn2 plus. So 2 MnO4 minus are going to accept 10 electrons to give 2 Mn2 plus. In the same manner, H2C2O4 releases 2 electrons to give CO2. Okay, so 5H2C2O4 is going to give 10 CO2 and 10 electrons. So N is equal to 10. Ananya, trying your best does not work here. Okay, so trying your best will not work. Either you have to do it or you don't do it. I hope today we have finished off with this, almost finished off with this chapter. We are going to talk about electrolysis and electrochemical batteries. Batteries we are going to talk about in tomorrow's class. So N is equal to 10 and Q is this. You change the balancing, the coefficients of N and Q both are going to change and they are going to balance each other. Is it clear? So now let's do some questions. Or should we talk about the NCRT first? No, we are going to do some questions. NCRT के करते हैं questions. That would be good. So let's read through NCRT first, and then we are going to do a few questions of NCRT. Okay, so here we got about the electrochemicals. Priyanshu Ghosh, NCRT is right in front of you. So we are going to talk about this chemical reaction can be used to produce electrical energy, and well, today the session, I have really enjoyed this session. Although it has been now, it's going to be near about 5.5 hours. Still, I'm not feeling tired. This is the way we are going to do the sessions next time onwards. We'll enjoy. Okay. So here we have the electrochemical cell. So this is the Daniel cell. Now, NCRT is a little bit haphazard. I feel like it's not very smooth flowing. I hope that today's session, if you have actually attended the today's session, it would be easy to understand what NCRT is. Now, I believe this particular cell you are able to see nicely. This is a question. An electrochemical cell becomes electrolytic cell if the external potential is greater than the cell potential. Okay. If external potential is less than the cell potential, then in that case, it is electrochemical cell. Clear? So if you wish, you can go along with the subscription, the course itself. We are launching the course. If you wish, you can go ahead and join in the plus course as well. The plus is going to be even better than this because there the two-way communication is right there. Okay. Fine. You have read this? Read this diagram? I hope you have your NCRT with you. Figure 2.2, what is it trying to say? It is trying to tell you that if we put the external potential and the potential of the cell, what exactly are the relations? In this case, it says that external potential is less than 1.1 volts. So what happens is what the cell decides. Now, cell is going to be working as an electrochemical cell where it is going to produce the electricity, and electricity is going to flow through the circuit because of the cell. But when we talk about this particular case, when E external is equal to 1.1 volt, this is an equilibrium which has been established. So no net reaction is taking place in the cell or external circuit. No electrons flow of current. So it is a null point which we get. Okay. Now, when we talk about this particular case, here the external is going to be greater. Now, this is going to be what says electrolysis. So electrochemical cell becomes an electrolytic cell when the external potential is higher. Is it clear, Priyanshu? This is what it is trying to say. And whoever has not liked the session, go ahead and like the session. Now, these are the galvanic cells. I don't know why they are talking about. They have not even talked about what reduction and oxidation is and why they are talking about this. So here it is the cell reaction that we have already discussed. No explanation. So these are reduction, half cell reaction, oxidation, half cell reaction, half cells or redox couples. The copper electron may be called the reduction half cell and zinc electrode the oxidation half cell. We can consider innumerable number of galvanic cells or called salt bridge. Okay, a salt bridge is not a necessity. There may be certain reactions in which the salt bridge is not required. Okay. So here is the definition of electrode potential. A potential difference develops between the electrode and the electrolyte, which is called the electrode potential. I hope you are reading it through. Quickly read it. And if anybody is to ask anything, just ask it. I'm waiting for your questions. Have you read through it? This is all we have already done. Any kind you want to ask here, any language you are not able to understand, I'll explain it thoroughly. So we are doing everything. We are doing NCRT reading, we are doing the questions, we are doing the solutions, we are doing the explanation, we are doing everything. We are completing the chapter thoroughly. So Ananya Sakar has no doubt in this page. Tirthaj Mukherjee has no doubt in this page. Nobody has any kind of doubts. So here we have talked about how we can find out the potential difference. Any kind of confusions in this part? Just read through it, read through it. I don't know why they have put the measurement of electrode potential first and then the standard hydrogen electrode. The sequence is not matching, but I believe you can understand it thoroughly. I believe there would be a feeling of elation. Now you are able to understand NCRT thoroughly. Please tell your friends how the session went so that I can have a few more students in the next class. Okay? Are you getting that feeling of elation? That yes, you are able to do it. Which diagram, Ananya Sarkar? The standard hydrogen electrode. Can you feel that? Now you are feeling that yes, you can clear the NEET examination now. Diagram 2.2.1. 2.2.1. It is nothing, beta. It is just a standard hydrogen electrode diagram. This is standard hydrogen electrode diagram, nothing more than that. Now you are looking at a confusion. Wow, this chapter must have some confusion in it. Where is the confusion? There is no confusion in this chapter anymore. Now Ananya is so confused. Where is the confusion in this chapter? Beta, this class is much better than your offline class. I'm able to move from one thing to another fast, very fast. It is better than your offline class. And if this class had been on the Plus platform, you would have seen it. Okay. We can have this class on the Google Meet. We can have this class anywhere. Okay, go ahead. Anything you want to ask here? This we have already done. Okay, reading. Have you read it? Read it through. Anybody who has not marked the like button, you have to press it once, not many times. Mark the session, mark it, and you just read through it. Any value, anything you want to read and ask it. Reading, go ahead and read it, no problems. Take your time, take your time. I have all the time in the world. Done? Read further. Here we are talking about the platinum or gold being used as electrodes. Most often they are used as electrodes when we have gases involved, because gas electrode can't be created. I think I should be shifted. Uh, wow. Isn't it looking good? I won't be hiding the NCRT anymore behind me. Wow, Prerna, you are able to understand everything? That's great. So just read through it. Anything you want to ask here? Ananda, this is going to be the best way, I believe. So now let's have the in-text question. How would you determine the standard electrode potential of the system Mg2 plus Mg? I believe the entire answer is at the end of the chapter. No, this answer is not given. Any problems here? Great, Tejas, but don't make a silly mistake. Don't make a silly mistake. Otherwise, I'm going to wring your neck. गर्दन मार दबा दूंगा तुम्हारी. Okay, and then what happened? So done. So this is what we have as the Nernst equation. We are not going to go into the derivation of Nernst equation. We are just going to use the Nernst equation. Here it is ln. Remember, ln x is equal to 2.303 log x. So 2.303 is a factor which we use to convert the natural log to the log to the base 10. Do all these questions and you have to send it to me. Any doubts? The Faraday's constant is 96487 that they use. Done? This is the electrochemical series. So this is the potential. Now this question was actually asked in the exam. So read through it. Doesn't make much of difference, Priyanshu. Doesn't make much of the difference. You can use 96487 or you can use 96500. It is better you use 96500. Unnecessarily no need to increase the calculation, but doesn't make a difference. And most often you are not going to use any of these. You are going to use 0.0591, which can be most often rounded off to 0.59, and some people round it off to 0.0506. Doesn't make a difference because you have to mark the correct option, and these options always have this much difference every time. Okay. Read through it. You are reading your NCERT books and you are marking in them. You need to ask whatever problem you have. Take a class on this chapter in app. We will be well prepared. We are going to take the questions in the app. Yes, we are going to take the questions in the app, and that is going to be tomorrow. Okay. Read it. Read this particular part. Any confusion with example 2.1? The same question was in the exam, but here instead of 0.130, that was 0.1. That's it. Anything you would like to ask? The one thing you need to understand that you can have the relation of the cell potential with the equilibrium constant. We have delta G. Delta G is equal to minus NFE naught. Okay. Delta G is equal to minus NFE naught. And delta G is also equal to minus 2.303 RT log K, where K obviously is the equilibrium constant. Okay. So that would mean that minus NFE naught is equal to minus 2.303 RT log K. What we can do is, first of all, we can just cancel out this plus, this minus, and this minus go. And then we get E naught is equal to 2.303 RT log K by NF. Now 2.303 RT by F, that is equal to 0.0591. Okay, now I am going to go to that side. Okay, and I get E naught is equal to 0.0591 by N log K. So we get the relation as log K is equal to N E naught by 0.0591. So this is what we can have as the relation between the cell potential, the electrode potential, and the log, the equilibrium constant. Any doubts here? Is it clear? So this is the equilibrium constant from the E cell. We have got 23 likes. Anybody is there who has not liked as yet? And this session needs to be shared with all your friends. And ask your friends to join in the next session that is going to be tomorrow at 4 p.m., where we are going to do the electrochemical, the electrolysis and the batteries. and hopefully in the same manner. Clear? Read this example. Read this portion. Anyone has anything to ask in this? You have to write these answers in your copy. Clear? I'm giving you the time for self study till tomorrow evening 4 p.m. I believe this is going to be the first time, I don't know from how long, that you have actually studied this long, isn't it? I'm really feeling proud today. I hope you are also feeling quite elated. Okay, so here is the in-text question. You are back in form. Back in form. Okay, I never thought you lost the form. I'm ending up the class now. We are going to do these questions again in the next class. Clear? We are going to do these questions. Tomorrow we have the class at 4 p.m. and that class is going to go on till 7 p.m. So be prepared for that. Okay. Join our Telegram channel for YouTube classes, PDFs, t.me/NEET Elixir. NEET UG subscription, Iconic Plus Plus. Go ahead and join it if you wish to. That's perfect. Okay. Use the code AVLive. Download the Unacademy app if you have not downloaded as yet, and use the code AVLive for that. Subscription you can take. This is my page on Unacademy, unacademy.com/Anoop Vashishtha. Follow me there. Like, subscribe, share, and comment. Subscribe NEET Elixir by Unacademy. Best live classes. Share, like, subscribe. We are gonna meet tomorrow at 4 p.m. Till then, bye bye. Take care. Thank you.